Hi everyone, today we are going to learn how to write and graph inequalities. So inequalities are used to represent expressions that are not equal, hence the name inequalities. So there are 4 inequality symbols that we need to know, and they look like this. So the first one, we read this symbol as is less than. So if you notice here, each inequality symbol has 2 sides. It has an open side and then a closed side. So you can think of these they look kind of like an alligator. The alligator always wants to eat the larger number. So the larger number is here, which means this is the smaller number. So we read this symbol as is less than. Another way to read that is fewer than. Fewer than means the same thing as less than. So if you have a number here that it's smaller, we say is less than. Now, if you see a symbol like this, notice now the alligator is trying to eat this number, which means this number is larger. So we read this symbol as is greater than or is more than, but this is the symbol for a larger number. Now, if we move over here, these 2 symbols look almost exactly the same, except they have this extra line underneath. So that extra line means or equal to. So for example, if I cover up the line, we have less than or equal to. Or here we have greater than or equal to. So let's go back to this less than or equal to. Another way that you can say that expression, you can say is at most. For example, if we're at like an amusement park and there's a ride that's just for little kids, they might just say you can ride this, or the height requirement for this ride is at most 48 inches, or they might say no more than 48 inches, which means it's okay if you're 48 inches or anything less than that, but that's the most it can be. So if you ever see is at most or is no more than, it means it must be less than or equal to that number. So that number is the highest it could be. Anything lower is fine. Now let's go back to this one, is greater than or equal to. So now let's think of a different ride at an amusement park, maybe one that goes upside down. So there's a height requirement. So they might say you must be at least 48 inches to ride this ride. That means 48 inches or taller. Or you could say you must be no less than 48 inches. So if you see at least or no less than, it means that the number must be greater than or equal to that value. And then a few other key phrases or words that we might see. We covered this way back in chapter 1, but if you ever see the word sum, it means to add. If you see the word difference, it means to subtract. If you see the word product, it's telling you to multiply. And the word quotient tells us to divide. So we're going to use a combination of all of these phrases and words to help us translate a sentence into an inequality. Okay, so let's try this first one together. Here it says a number, W, minus 3.5 is less than or equal to negative 2. So let's just start translating from left to right. Here they tell us a number, and they even tell us which variable they would like us to use. A number, W. The next thing we see is the word minus. So we will literally write a minus sign. The next thing we see is 3.5. All right, now the next phrase we need to be careful with. It says is less than or equal to. So that means this value is smaller, so less than. Notice that the closed pointy side is facing my smaller value, but then it also says or equal to. So make sure you add that extra line in the bottom. Is less than or equal to, and then we have negative 2. And this is our sentence written as an inequality. Okay, go ahead and pause the video and see if you can translate these 2 sentences into inequalities, and we'll check the answer in just a few seconds. Okay, so here it says a number is fewer than, which remember also means is less than 30.4. So B is less than 30.4. Here it says twice a number, K. Twice means to multiply by 2. It literally means 2 times. So 2 times K is written as 2K. is at least. So remember, at least means it has to be greater than or equal to. At least means it must be that number or more. So 2 times k is greater than or equal to negative 7 over 10. Okay, so here, now we're going to see if we can figure out if a value is a solution of an inequality. So inequalities actually have a lot of solutions to them. For example, going back to the amusement park ride, if it says that you must be at least 48 inches, 48 is fine, 49 is fine, 50 is fine. So there's a lot of possible heights that work. So inequalities actually have a solution set that is pretty large. So the way you check to see if a value is part of the solution set is you substitute that value into your inequality, like you see they did here, and then you look at the expression you get. If you end up with something that is true, like -1 is greater than or equal to -2, then yes, it is part of the solution step. Same thing for -7. You can see here they substituted -7 into our inequality, and what you end up with is a true statement because -2 is greater than or equal to -2, which means -7 is a solution of the inequality. Now, if we're checking x equals -8, we end up with the statement -3 is greater than or equal to -2, which is not a true statement. -3 is actually less than -2. So since we end up with a statement that is not true, the number 8 is not part of our solution set. So we say it is not a solution. So let's try going through this process. We want to see if -4 is a solution for both of these inequalities. So remember, the way we do that is we substitute the value we want to check. So here we want to check -4. So -4 plus 8 is +4. And if I'm wondering, is this a true statement? Well, let's read it from left to right. 4 is less than -3. Now we know that this is not a true statement, right? Because 4 is greater than -3. So we would say, no, it is not a solution of that inequality. Now let's check this one. Here we have -4.5 times our value, so times -4. So let's do a little bit of multiplication. So 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. And then we need to count how many times to move our decimal. So we have 1 movement here, so we do the same thing here. So it ends up being 18. Now we know a negative times a negative becomes a positive. So this says positive 18 is greater than negative 21. Now this is a true statement. 18 is larger than negative 21. So you would say, yes, this is a solution for the inequality. All right, go ahead and pause the video and see if you can try these 3 examples. See if -6 is a solution to those 3 inequalities. Okay, let's check your work. So you need to be careful with your substitution, especially for number 4. But let's start with number 3. -6 plus 4 is -2, and -2 is less than -1, so it is a solution. Now here when I substitute -6, remember, I would like you to rewrite this as 5 plus 6. 5 minus -6 just means 5 plus 6. So 11 is not less than or equal to 10, so -6 is not a solution there. Here, 21 divided by -6, I did my long division here. Remember, if you're doing long division and you run out of numbers, so we did 6 goes into 21 3 times. 3 times 6 is 18, and we subtract, and we end up with a remainder. That means we're not done. So we need to add a decimal point and a 0, and then we can bring down the 0 and do another round. 6 goes into 30 5 times. 5 times 6 is 30, and when you subtract, if you end up with a remainder of 0, you know you're done. So 21 divided by -6 would be -3.5, which is greater than or equal to -3.5, so yes, it is a solution. All right, the last thing we're going to talk about is how to graph the answers for our inequalities. So we graph inequalities on number lines because remember, inequalities have a large solution set. There's a lot of numbers that work for the solution. So to show that, we're going to use a number line and we're going to start by placing a circle on the value. Now, if you're working with greater than or less than, we use an open circle on the number to show that it's not part of the solution. But if you're working with less than or equal to, or greater than or equal to, you need to use a closed circle to show that it's part of the solution. So if you have the line, you need to use a closed circle. Once you have your circle placed, you have to decide which side to graph your answers. So if you're working with less than, you're going to graph the numbers to the left because those are the numbers that are smaller. But if you're working with greater than, you're going to graph the numbers to the right. And you do that just by tracing an arrow to either the left or the right. Okay, so let's give this one a try. If I read this inequality, it's read y is less than or equal to -3. So I'm going to find -3. And since I see that or equal to part, since I see the line, I know that I need to use a closed circle. Now, since this says less than or equal to, I know that all of the numbers that are less than -3 are part of my solution. And remember, when you see less than, that means to graph to the left. So you just draw an arrow moving to the left and you're done. So this shows that all of these numbers work for this inequality, including -3. Okay, go ahead and pause the video and see if you can graph these 3 inequalities. Notice for your number lines, you don't have to center it around 0. For this first one, it's -8, so I'm going to center it around -8. You don't need to start at 0 to make your number line. So pause the video, give it a try, and we will check in a few seconds. Okay, let's go ahead and check our answers. So for number 6, the inequality reads b is greater than -8. So I'm going to use an open circle because it is also not equal to. And since it's greater than -8, I'm going to graph the numbers to the right. So an open circle with an arrow to the right. For number 7, this inequality reads g is less than or equal to 1.4. So I'm going to start at 1.4, which is somewhere between 1 and 2, and I'm going to put a closed circle because I see the or equal to. Now, since it's g is less than or equal to, I graph all of the numbers that are smaller or less than 1.4, so to the left. For the last one, -1/2 is somewhere between -1 and 0. So since its r is less than -1/2, I have an open circle and I graph to the left. Okay, that is all for today's lesson. Thank you so much for watching.